All right, everybody.
Salty.
The usual morning festivities over with.
Nice job.
Let's. What we're going to do today was yesterday we saw how to make or the formulas for the derivative and integrals of logs and exponentials. Okay. Your homework last night was to basically calculate the derivatives of some logarithmic functions. Okay. So what we're going to go with to do today is basically just go over that homework. Okay.
What are these called? Transcendental.
Transcendental functions. Okay. Is the general.
Impossible.
Yeah.
Is this what Thoreau maybe came up with?
Who?
Transcendentalism?
No. It has nothing to do with that. Okay. All right.
That's kind of funny.
Nice job.
So 43. Let's start off with this one first. Okay. What we want to do here is we want to find the equation of the tangent line to the graph of the logarithmic function at the point 1, 0. Okay. So we want tangent line to y equals the natural log of x cubed at the point 0, 1? I think it's 1, 0. 1, 0, yes. Because at 0, 1 I was about to say, that's not doable. But 1, 0 is doable. Okay. Alright, first thing I want to quickly do is make sure, is 1, 0 actually a point on this line? Okay, what's the log of 1? 0. So yes, 1, 0 is actually on this line.
Log base 10 of 1?
Log base anything of 1 is always 0.
Right.
Okay, so the natural log of 1 cubed would be natural log of 1, which is still 0. Okay, because what do I raise e by to get 1, basically? The answer is 0. Okay, so 1, 0 is a point on this line, so we wanted to check that first. We're good there. Okay, so we're looking for the tangent line. Okay, so before I do anything else, I'm going to write up the tangent line equation. Okay, so I know, hey, this is the equation that's going to give me that. The tangent line equation, remember, is y minus the specific y is equal to basically the derivative of whatever our function is. So we'll call it f prime of x sub 1, okay, times x minus x sub 1, okay? This is our tangent line equation. Okay? So, we've got y1 and x1, that's 1 and 0. What we need is f prime of x sub 1. Okay, that is, we need to figure out the derivative of the function and then evaluate that at the given x coordinate. Okay, that's basically what it's asking for. So, in order to fill that part in, what's the derivative of ln of x cubed?
Darn it.
Okay, whatever. Okay, what's the derivative of the natural log of x cubed? Remember that from yesterday? What would it be? So it's 1 over x, so the derivative,
Oh, it's 1 over x.
x cubed is 1 over x cubed, is that it?
Times the natural log of, no, times x cubed. Times 3x.
squared.
3x squared. Okay. There you go. Remember, okay, it's the derivative of the natural log is 1 over x, or 1 over f of x times the derivative of f of x. That's what it comes out to be there. So we're going to evaluate this thing at 1. Okay, so 1 over 1 cubed times 3 times 1 squared is going to be equal to what? Should be easy.
3.
3. Because that's just 1, and that's just 3. So our answer is 3. So we did all that just to get a really easy answer. So our tangent line then, filling all the pieces, would be y minus 0 is equal to 3 times x minus 1. And I'm done. I don't have to go any further than that.
What's how do we know that 0 is a point on that line?
Oh, we just test it out. You put in yeah, x equals, you put in 1, because we're at the point 1, 0. You put in 1 in for x, and see if you get 0 as your answer. The natural log of 1 is 0. Okay. Any questions though?
Make it a lot easier than
Then it actually is.
Yeah.
Well, no, but then we do it and it's really hard.
But it shouldn't be. It should be this easy every time.
But
All right.
It doesn't work out like that.
Well, how about this? How about one of you guys come up here and do 45 for me?
Wait, what is the? No, I
Hey,
didn't.
so good, you got it, man.
Totals definitely got it.
45.
So you have to trick to 45 though.
This isn't like too.
They're a trick to 45.
There's no. Log.
What's the problem?
There's no log.
There's no log. Actually, I can tell you why there's a problem with this one. It's a misprint. This is a typo.
What is it supposed to be? ln of that?
It should be ln of natural log of. Okay, because the dead giveaway of why there was a problem there was is 1, 0 a point on x to the fourth?
No.
No. The point would be 1, 1, not 1, 0. So, this is the correct problem. All right, who wants to take this one? Right up here on the board. Volunteer. Don't make me pick.
But why wouldn't 1, 0 be a point on?
X to the fourth? Because what's, okay,
Plug in one.
you plug in 1 to x to the fourth, do I get 0?
Oh well, no. What about ln x to the 4th?
Yes, in that case it is, but the problem in the book was x to the fourth. And that's why I looked at it and said,
Okay.
that there's a problem with that, that's a typo, it has to be a typo. You
Alright.
gonna take it?
I'll do it.
Alright, come on up here.
Wait, so when you plug in one, it comes out of 0?
Yeah, if I plug 1 in that thing, it comes out as 0. So you just want to check to make sure the point's actually on the line. It is. Okay.
Why wouldn't it be
What's 1 to the fourth?
1?
1. And the natural log of 1 is?
I'm gonna give it 0.
It's always 0.
Why?
Okay, because, pay attention here, alright, remember when I've got something like natural log of 1, this really means what do I raise e by
Should I go for the 2?
to get 1?
0?
0, because anything raised to 0 is always 1.
Oh yeah.
Okay, and so, because remember, the log base e of 1 is what natural log of 1 means, okay?
Wanna do it?
Okay, is he right?
Um,
What mistake did he make?
Go back up there. It's numerous.
No, there's only one mistake he made.
X minus 1.
It's x minus 1, there you go. You messed up the,
Yeah, what is that?
the tangent equation. Should be minuses. Okay. X minus 1. There you go. Now it's correct. Perfect. Okay. The only other thing I'm going to fuss at you about, because it's my job as a teacher to fuss at students who don't do things right. No, whatever. His handwriting's fine. My handwriting is atrocious, so I'm never going to yell at you about your handwriting.
What was his
Unless I
mistake?
can't actually read it, then I'm just going to tell you to rewrite it.
Mr. Dowell, what was his mistake?
The mistake, the actual math mistake he made was,
I would be in trouble.
he put that as a plus at the end, it should be a minus.
Oh.
Because
It's like that's
Yeah.
a D
I think he just
proportional.
misread his mark there, I think he just had an extraneous, that's what that should be right there, okay? But then the thing I'm gonna fuss at him about, as just me being a math teacher notation wise,
God,
down here, you don't need to put the d by dx in front of the derivative, because you already know it's the derivative. You could go, if you really wanted to, you could say d by dx is equal to that, and you're done. Or f prime is equal to that, okay? But what you have written there would say take the derivative of this thing, which would be a different answer. That would be a quotient rule. Actually, you wouldn't have to do the quotient rule on that, but you could. It'd be an easier way to handle it. Okay? Good. Excellent. Well done. All right, that was 43 and 45. 47, what we're doing is we're just finding the derivative of the function. Okay? So can I get a volunteer to come up here and do 47? This one's super easy. Who wants to take it? It's like super easy. Come on. It's like easier than making easy math. Yeah. Go for it.
No way. It's definitely not easy.
Some people forget to put
This
the
is water. Water and heat.
That's it, he's done. Excellent, okay? So,
Wait, you don't have to do,
yeah, because all we have to do is the derivative. That's the derivative of the natural log of 3x. So 1 over 3x times 3.
God, that's
Yeah, that's not that hard, is it? Okay. Let's have another volunteer. 49. Okay.
What was the answer to the one you did?
Volunteer for 49.
Y minus 0.
I did it.
Come on, why don't you do it?
X minus 0.
I get 4. You
Take it away.
One, get 4.
No, because the derivative of ln to x to the 4th equals 1 over x to the 4th times 4x to the 3rd, which you put in 1, so you get 4.
I kind of forget what I did, so. I don't know, just now.
Well, let's start from scratch. Okay. What's the rule?
1 over x.
Okay, so 1
Isn't
over.
this?
Is it? But is x here? It's
Isn't this problem? My problem was written down differently.
okay. Well, that's the one that's
Okay.
the one on the board.
Okay.
Okay. So natural log of x squared. So it comes out to be.
There's 1 over x.
Well, look what Tilly did.
You go camera shot.
Square.
Yeah, okay, thanks.
And what am I multiply that by?
X.
That's a good one.
Is it just x?
That's classic.
Just derivative of that.
It's the derivative of x squared.
Yeah, that's good. Alright.
There you go. Perfect.
Alright.
That's it. Okay. Better now?
Yeah, mine is different. So I just tried to do the thing I did on my paper. And it's
Okay.
just totally
It
different.
all comes from, again, the formula here, everybody. Okay? And the formula for a natural log. So the derivative of the natural log of a function is 1 over whatever that is times the derivative of it. Okay? That's it. That's all we have done. So, Teddy, why don't you come up here and do, let's see.
No, please just give me an easy one.
I'm giving you an easy one. I'm finding an easy one. Why don't you do, this one actually wasn't assigned for homework, but it's easy enough to do. Okay? Give me the derivative with respect to x of the natural log of x squared plus x to the 4th. Let's do x squared over 4. What's that equal to?
Are you serious?
It's easy enough to find. You do that. Look at the rule. What's the rule say I do? It's going to be what? 1 over. Okay, so far so good. Then what?
Yeah, I guess. Sham rule it, right?
Do I,
No, quotient rule it.
do I have to do the quotient rule? What? What's in the bottom? What's 4 on the bottom?
Constant.
So I can prove that out as a 1/4, right? So it's 1/4 times x squared. What's the power rule tell you that's going to be?
I don't need any help. No, I'm just kidding. Is that it?
There you go. Perfect.
Wait, why don't you have to do the chain rule?
You did do the chain rule. That's what the chain rule says. Okay? The derivative of the outside, so the derivative of the element of x is this right here,
Yeah.
times the derivative of the inside, which is what that is right there. That's the chain rule.
Wait, how do you know you don't have
Yeah.
to do?
Kid,
that was
great.
Yeah, I didn't
Oh,
know.
because it's just a 4 at the bottom. If it was 4x, it'd be a quotient rule.
Oh, yeah.
It's a constant, so you could just pull it out as a 1/4. Okay? Which is exactly what I told Tate to do. Okay? Yeah, easy, right? This is not super difficult. Okay?
But why are we just working with the natural logs?
Because we're going to work here in a minute with the logs. It's the second half of the homework.
Just regular,
Yeah, so the starting off is with the natural log.
yeah.
Then we're going to do the ones with the logs next.
Right.
Okay. Alright? This should not be all that difficult to do. You're just following a formula, really, and the formula is just, you're doing a derivative of a natural log, it's 1 over whatever the thing was behind it, times the derivative of whatever was behind it. Okay? Let's look at the first one, and I'm going to do it up here. Okay? The first one of any difficulty, okay, that we're going to see with these natural logs. And we want the derivative of the natural log of x, all of it, the fourth. Okay? Now why is this tricky?
It's a change.
Chain
It's
inside.
actually a chain rule with a natural log inside of it. Okay?
It's a double chain rule.
So you can think of it as a double chain rule if you will. Now luckily, natural log of x is an easy straight up derivative. Okay, so we really don't have to worry too much about that. But we do have to follow along what this thing says to do. Okay? So this thing will come out to be, if I follow the rules, I'm doing the derivative of the outside first. So the derivative of the outside would be, basically doing 4 to the third, like so. Okay? Now what's on the inside there?
Same thing.
Same thing. So it should be natural log of x. But then I'm going to multiply this by the derivative of the inside. What's the derivative of the natural log of x?
1 over x.
1 over x. Okay? Had that been something like 1 over x squared, then I'd do, again, a little chain rule on top of it. But since it's just 1 over x, I don't have to worry about going any further. Okay? So that's how that one would come out to be right there. Okay? That's about as tricky as they're going to get. Okay? So variation on, there's variations on this one. So like for example, let's do another one. Let's look at 53. 53 is one that wasn't assigned for homework, but it's a good one to look at. Sorry. That would have been really tricky and mean to do. Actually, let's do it this way. Let's see who gets this.
Nope.
What would the derivative of this be?
What is that? T minus 1?
T minus 1 squared.
Yeah,
The
but
natural
I-
log of t minus 1
Do
squared.
not do the
Because I
same
saw
thing.
T and I didn't know what to define it as.
Okay,
That really messed with me.
right.
Do you not do the same thing?
Look at this carefully. What is it asking you to do?
Oh, it's the derivative with respect
Alright,
to
well, I
x.
got it.
Derivative with respect to x of,
The natural log
Of
T
t.
minus one.
so is tx?
Is it implicit?
No.
Yeah.
No,
So
it's not implicit.
So it's not a solution.
It's
No, it's not a
X.
solution. What would all this be then? If it's not in terms of x, it's just a,
It's the same
Straight up
thing.
thing,
It's a
same
constant.
thing.
it's a constant. What's the derivative of constant?
One. Oh, you dog.
Zero.
Whoa.
That's why.
Whoa!
Yep. That's why, everybody. Okay. That's why it's important to know what the variable you're using is for differentiation integration, because it really changes how the answer comes out to be. There's no x in this thing. Okay. I'm supposed to be taking the derivative with respect to x. There's no x in it. Therefore, the answer is just 0.
So what was the book saying when it was like the integral of 1 over t?
Oh.
It's like the natural log equals the integral of 1.
So over this right here,
Yeah.
okay, that's just defining what the,
So that's the same thing we did
yeah.
before.
basically it's defining,
I think it used x, the natural log of x.
right, what they did here was the actual thing in the book, the rule written in the book was the derivative from 1 to x of 1 over t dt is equal to the natural log of x.
So I didn't
Okay,
understand.
that's from the fundamental theorem of calculus. Okay, all it's doing is telling you what the integral of 1 over x is. It's L of x plus c. Okay, because if I evaluate this using the fundamental theorem, I have natural log of x minus natural log of 1, which is just natural log of x. Okay,
Wait, Mr. Dowell,
Yeah.
I forgot, if you have like if you're doing the integral and you have 1 on the top and like negative 1 on the bottom, do you have to subtract, or do you add or subtract the two numbers?
it's always subtraction. So basically, if I had like the integral of minus 1 to 1 of f of x dx, for example, this would just be big F of 1 minus big F of negative 1. Okay?
Okay.
It's always,
What's that called again?
this is just a definite integral.
Yeah.
Okay? It's always, and it comes from the fundamental theorem, first part, it's always like that.
Right.
Okay? Top number, antiderivative of the top number minus antiderivative of the bottom number. Okay? That's why it comes out this way. Better?
Are you almost out early today?
By the time I let you guys out already? Really?
Yeah, we did.
No, 15.
No, you guys have like 15 more minutes, right?
Yeah, I know.
Prepare for our worst class.
Okay. Now, going back though to the problem I had actually wanted to look at would be the derivative with respect to t of the natural log of t minus 1 squared is equal to 1. Now, how would that one come out to be?
1 over t minus 1 squared.
Okay, so it's 1 over t minus 1 squared times what?
Times, not chain rule.
Chain rule of that, so it'd be 2
T minus 1.
t minus 1 first times the derivative of t minus 1, which is luckily just 1. Okay? And so that would be the full answer there. Okay? Good. Okay, that again, those are about as tricky as you're going to see. Okay? But basically, like, the standard rules of differentiation apply. So power rule, chain rule, quotient rule, that sort of thing will apply. It's just that whenever I do the derivative of a natural log, it's just a special derivative, okay? So, let's take a look at the second half, 1 through 7, okay? So these are ones where I'm finding the definite integral, okay? But they're written, these are definite integrals, okay? Written in the form of 1 over x, basically, okay? Or something along those lines. So, for example, my first one, I've got the integral of 5 over x dx, okay? Basically, I want to take the antiderivative of this, okay? How I'm going to go about doing that is 5 is a what? It's a constant. What can I do to constants? I can factor them out, right?
Yeah.
So I'm going to go ahead and do that so I illustrate what happens here. And what's the indefinite integral of 1 over x dx equal to?
Natural log.
Natural log of x plus c. So this thing becomes 5 natural log of x plus c. And that would be it. Okay? Any questions there?
That's tricky.
Yeah, that's how it's going to be. It's a single thing. Okay? But then things get a little bit more tricky, like number 3. Okay? Number 3 of 1 over x plus 1 dx. Okay? Now we know how to do the integral of 1 over x, but how do we do the integral of 1 over x plus 1? Seems like we'd have a problem, right?
X plus 1.
It'd be, okay, so your guess is it should be the natural log of x plus 1. Okay? And you're actually going to be right. It is going to come out to be that way.
Plus C.
Plus c, well, obviously, yes. Okay. But why it comes out that way takes a second or two more. It's not so, this one is fairly easy, so you can see that's what it should be like. In reality, what you're doing here is a u substitution. Okay? You're going to come through and you're going to say, let u be equal to x plus 1. That means du should just be equal to the derivative of x plus 1, which is 1 dx. Okay? So this thing should come out to be the integral of 1 over u du, which would be the natural log of u plus c, which when we substitute back in, comes out to the answer you gave us. Okay?
The du is what?
Basically just dx, 1 dx.
But so you did substitution there?
Yeah, I ended up doing substitution, which is technically what you're supposed to do there. Because the bottom here isn't x, it's x plus 1. Okay?
Wait, so
So, in our next one here, and I'll let you copy this one down real fast before we do our next one like this. Okay?
wait, so why did you just put an ln in there because of 1 over u?
Yeah, 1 over u, and again, it all comes from the definition we went over yesterday, which was that the integral of 1 over x dx is equal to the natural log of x plus c. It's the one that Dr. Boson, if you remember, commented, do we take that on faith? And the short answer was yes. The long answer is no, there is a reason for that, but it takes a long time to explain. It's a Riemann sum, basically. If you do a Riemann sum of it, you would see the two are equal.
Why wouldn't we just set x plus 1 equal to f of x?
Well, that's what you're doing. You're doing a u substitution. Okay? It's just we don't use f of x, we use u. But no, that's exactly, if you want to do them that way, do them that way. That's absolutely fine. I do them as u because that's basically, that's what I'm used to doing, because that's the notation that's been used for the last 150 years for doing these sorts of things. Okay? But there's no reason you have to choose u. You could choose f of x. You could choose y. You could choose Batman symbol. Okay? The ideal, though, is you're making a substitution. Okay? So however you do that substitution, don't care about it as long as you do the notation correctly. Okay? Make sense?
Mhm.
All right, good. All right. Any questions on how one like number 3 works? What you're really doing there? All right. Well, let's take a look at number 5. Okay? Number 5, we have the integral of 1 over 2x plus 5 dx. Okay? Now, how do I want to handle this one? What rule do you think I'm going to use here?
Substitution.
Substitution. Okay? So, what am I going to make equal to u?
2x plus 5.
U would be 2x plus 5. What's du then going to be?
2 dx.
2 dx. Do I have a 2?
No, make
I'm missing it.
And then 1/2 on the outside.
So I'm going to stick a 2 inside of here and a 1/2 on the outside. Okay?
Yeah.
Everyone got that right there? Now I can do my u substitution to get this to be 1/2 the integral of 1 over u du. And what does that come out to be?
1/2 natural log.
1/2 natural log of u plus c. And we can leave our answer just like that. Okay? Alright, so things get a little bit trickier when I do them that way. What's another way I could have done this? Did I actually have to use a u substitution? Well, could I have made my u substitution easier? Or I'd done it more like the one before where it was clear it would just directly be equal to the natural log of the stuff on the inside and the bottom? I could have, because I could factor this 2 out, can't I? So I could have done this as 1 over, I could have factored out the 1/2, and the bottom I'd have x plus 5/2. Okay, dx. Then the 1/2 would come out in front. And as we saw before, that should just be equal to 1/2 the natural log of x plus 5/2 plus c.
Wait.
Okay, so it's kind of an interesting alternate way of doing things.
If you plug in, can you not just plug at the top, on the top right there, you did 1/2 ln u plus c?
Uh-huh.
And don't you finish that up by doing 1/2 ln and then substituting?
2x plus 5?
Yeah,
Yeah, you can absolutely do it that way.
but you have a different answer.
Do I really have a different answer down there? If I set them both equal to 0, do I get the same answer? Yes. Okay. They come out to be, ultimately they are the same. Okay? They look different, but they ultimately are the same. Okay?
Cool.
Yeah, I know, it's kind of weird how it can work that way sometimes, but it does. Basically, if I set that equal to 0, I get my answer is -5/2. If I set that equal to 0, I get my answer is -5/2.
Yeah.
So what does that mean they have to be?
Equal.
They're equal. Okay? As far as this problem is concerned. Okay? Alright. Yeah, math this way sometimes is tricky and weird. Alright. I want to volunteer for number 7.
Oh boy. It's 2 x's.
Whoops, -3. Okay, volunteer.
Contra?
Sure, come on up here.
He wants it.
Eager Ted.
Screen mode.
Right.
Equal.
Don't let me down, Ted.
Alright.
Eager.
Alright. Kind of kinda stuck now.
Okay.
Hold up. Wait, so if I have 2x, that means I have to put it right here and then put a 1/2 out.
Bingo. Yeah, that's exactly what you have to do.
Alright. Yeah, I'll do the way you do.
You don't need the full 2x, just the 2. You have the x already on the top. Sorry.
Wait, what?
You already have the x in the 2x.
Yeah,
Okay, there you go. Better.
yeah.
Now what?
Alright, so. I don't, wait, is that right?
Well,
What do I do with the?
what can I do with the 2x dx? What's that substitute to be?
du?
Yeah. So instead of writing it out, couldn't I just write it as du?
Wait, right,
Du
what?
over u.
The 2x dx.
Wait, right, right here?
Okay, you can put du right there. That's fine. But then what? I still have the 2x on the top of it?
I don't know.
Well, no. Did the 2x dx become du? Here, stop. One
You have to
second.
still put u in there.
Yeah, you still put u in there
Yeah.
because that's what u is right there.
Oh, so
That's
just
my
be
u.
du over u?
Yeah, du over u is fine. Yeah, and that's my du, right?
Yeah.
So I would have du over u, which is the same thing as 1 okay, or 1 over u du, right?
What?
Could I rewrite that as 1 over u du?
I don't, why would you do that?
Well, I'm trying to take the antiderivative, right?
Yeah.
So what's the answer going to be?
I'm so lost.
Okay,
I don't get what you would do from there, because it's not 1 over
yeah, it is.
du, but it's du. How?
Aren't
it's
those
a
things
const-
equal?
It's a, wait.
Not constant, but it's just algebra, guys. All I'm doing is writing it, the answer slightly different.
Oh.
They're the same thing. What happens if I multiply 1 over u times du? I get du over u, right?
Yeah.
So that's the same thing there. So
Well,
now
why
what's my
would you
final
want to
answer?
rewrite that?
Well, because it makes it clearer what you're going to do next. What's the answer going to be now?
1/2 ln u du
Plus c.
plus c.
Plus c. There you go.
Wait, what about the du though?
It went away when you did the antiderivative. It always goes away when you do the antiderivative.
What? Why? I never thought of one. But why does the du go over the entire?
Okay, because we're undoing a derivative. Okay, remember, basically, that's it. You can leave your answer like that. You don't have to go any further.
No, I like this.
Okay, if you want to make an x squared minus 3, that's fine. Okay, basically, why does the du always go away? Okay, it's because basically what we've got here is what we have originally right here. Okay, is the derivative of something. Okay, so when you're doing it, so before I take the integral, what I'm looking at is somebody's derivative, right?
Yeah.
And the integral is doing an antiderivative. That means we're reversing the process, okay? So, those dx's on the end, okay, which basically just stand for derivative of x, okay? When I undo them, okay, it's like I'm doing the antiderivative to a derivative. What happens when I do the anti-something to something? They cancel. So what keeps happening to those dx's? I'm doing an antiderivative to them, so they just disappear, okay?
Well, if the original equation's the derivative of something, you're taking the antiderivative, why is it not 0?
Because we're getting back to the original something. Okay? The only part that goes away is the dx. The rest of it was something's.
Wait, so we're just taking the antiderivative of
Yeah.
1 over u?
Yeah, 1 over u, the antiderivative of 1 over u.
So pretty
It's
much you
natural
just
log of
figure
u.
out what
Because the
d.
derivative
The
of...
natural log of u is 1 over u.
So you find the derivative just to figure out if you have to change the original and put like a
Yes.
coefficient?
Exactly.
Yeah.
Okay? basically, when you do a substitution, okay, we're essentially simplifying it down, and we're finding what the derivative of u is right here, okay? So that way we can make the adjustments we need to reverse things.
And then you just
Remember,
multiply.
Ultimately, okay, the answer down here, if I were to take the derivative of this answer right here, I would get my original, the thing I started with, okay? So if I followed the correct rules of integration on 1/2 natural log of x squared minus 3, I would get x over x squared minus 3 back, okay? And so that's why this process works. That's why we don't have to worry about this stuff once we change the du, okay? It's because it gets, essentially what we've got here is, you're doing, every time you do an answer by substitution, you're actually doing the chain rule in reverse. So remember, the chain rule was derivative of the outside keeping the inside the same times the derivative of the inside. So we're reversing that, the derivative of the inside stuff has to go away, and we're doing the antiderivative of the outside, okay? Which is essentially what we're doing here, okay? Is that clear right now?
Yes.
Alright, good. Okay, so in that case, hopefully this was useful, seeing how a bunch of these were done. Okay? Y'all